Assalamu alaikum. My name is Abdul Rafeh and my group member is Fawad. Today I discuss the topic heaps and its application. Things to cover: what are heaps, application of heaps and real life example of heaps. First one, what are heaps? A heap is a tree-based data structure in which all the nodes of the tree are in a specific order. For example, if the parent node, then the value of follow a specific order, with respect to the value of the same order will be followed across the tree. In a heap, the highest or lowest priority element is always stored at the root. The heap is one maximal efficient implementation of an abstract called priority queue. A heap is a useful data structure when it is necessary to rapidly remove the object with the highest or lowest priority, or when insertion need to be interspersed with removal of the root node. Maximum and minimum heaps. In minimum heap, the value of each node is smaller than its child, and in maximum heap, the value is greater than its child, as shown in a diagram. The second thing, application of heaps. There are many applications of heap. The first one is heap sort. One of the best sorting method being in place and with no quadratic worst case scenarios. And the second one is selection algorithms. A heap allow access to the minimum or maximum element in constant time, and other selections such as maiden or cat element can be done in sublinear time on data that in a heap. Graph algorithm. By using heap as interval traversal data structure, runtime will be reduced by polynomial order. The last one is priority queue. A priority queue is an abstract concept like a list or a map. Just as a list can be implemented with a linked list or an array, a priority queue can be implemented with a heap or a variety of other methods. The third one, real life example of heap. For example, heap sorting can be applied to a SIM card store where there are many customers in line. The customer who have to pay bill can be dealt with first because their work will take less time. This method will save your time for many customers in line and avoid unnecessary waiting. Applying heap through basic insertion and deletion operation. Here is a program. In first step, to happify a subtree rooted with node which is in an index of array and n is the size of a heap. In second, initialize largest as root left is equal to 2 static I is equal to 1 and right is equal to 2 static I plus 2. In third step, if left child is larger than root, and in fourth, the right child is larger than root so far. In fifth step, the largest is not root, and in sixth, recursively happify the affected subtree. Get the last element, replace root with the last element, decrease size of a heap by I. Happify the root node, and in this, a loop to print data store. The main function to store values, delete values and display values by calling function. And there is an output of a